Hey everybody, this is Larry. This is day 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Let me make it slightly smaller again. We have 264, ugly number 2. Hit the like button, hit the subscribe button. I think I always said about this. I don't know. Actually, I ended up taking a nap. I ran 10 miles this morning and then I did the bi-weekly, which I didn't do very well on. I think my Q4 is Q4 is wrong. So yeah. It is what it is. So okay, so we have this one. An ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Return the nth ugly number. Okay, so there are a couple of ways you can think about this. Yeah, I mean, I think the way that I would like to think about it is just kind of like not a breadth first search, but something like a breadth first search, right? Where you just generate the next number from the previous numbers, and keeping in mind that we only have to do that 90 times. That's all we need to do, right? Basically, for every number we know, okay, so we start with 1 and then we just go, okay, well, what's the next number that has an additional prime factor of 2, 3, or 5? Well, it's just going to be, let me comment, right? So 1, so you have 2, 3, and 5, right, in the pool. And then now, well, the next thing to pop is going to be 2. And then now you also go, okay, well, with 2 is the smallest number, what's the next numbers, right? So then that's going to be 4, 6, and 10, because these are 2 times 2, 3, and 5, right? And of course, you sort them as well. And of course, in theory, you just have this in a heap. And that's pretty much the idea. I think you have to do some other things just to make sure that it doesn't dupe. For example, now the next number is 3. Of course, 6 is going to be duplicate and you don't want to add that again. But I think that should be good enough. Especially since we only have like less than 2,000 numbers, right? So let's give it a try. Yeah. Yeah, maybe we have a scene just to kind of right? And then we have a heap, right? And then we have basically, I was going to say an array, but you don't even need that, right? You don't need the numbers at a time. You just need the heap. So then now we push 1 to the heap. And then what we want to do is just pop n times, right? So because the nth pop is going to give you the best answer. So then now we have, and also we're going to see n is equal to 1, though that shouldn't matter, but you know, just for consistency. So current is equal to heap q dot heap pop. Actually, it should be n minus 1. It depends how you want to write it, but then now the top of the heap should be the answer is why I want to do n minus 1, because then now we pop n minus 1 times. So yeah, and then now we go, okay, so then for next value is going to be equal to well, we just count 2, 3, and 5. And then here we want to say if current times next, or maybe this is like m for multiply, and then next is equal to current times m. And then if next is not in scene, then we can just add it to the heap. If I can somehow type it correctly anyway. And yeah. And that's really it, right? Oh, I always forget. I'm trying to think whether this is an off by 1 thing, or am I just, because you know, this is off by 1. Oh, because we already have 1 number in it. Wait, is this? Oh, this is 1 index, that's why. Okay, so if it's 1 index, I guess we do this. Still wrong somehow. Alright, let's take a look. Oh, I'm dumb. I just forgot to add, oops. Okay. Yeah, looks okay. And then now, you know, just for, I know that we have done it before, but I wanted to be more honest about it. And this looks okay, right? And as you can see, this answer grows very quickly, right? So this is like 2 billion, which is you know, you can't do like a crazy DP thing or whatever. Let's go quick submit. And yeah, pretty straightforward. 1601 day streak. Yeah, the idea here is that we keep on getting the smallest number, and we can generate the next numbers based on these prime factors to ensure that it is true. And there are basically a couple of invariants here, right? I talk a lot about invariants, and you have to kind of identify it, which is that inside the heap, every number inside the heap satisfies this condition, and because we generate it from that way, where every number that we pop off, and then we keep it still inside the same universe or the same invariant. So that's basically the idea. I think the one thing that you may be concerned about is, well, you ask, how fast does the heap grow? What if there's too many things, right? But it turns out that because for every number that you pop off, you're only going to generate 3 numbers. And it's very easy, and I think I've done this in the past by accident in analyzing it to myself, right? Is that I thought, okay, well, wouldn't this be exponential, right? And you know, if it's exponential, it's not going to be fast enough, right? But the thing is that for every number that we pop from off the heap, we only generate 3 numbers. So even let's say this is 2000, that means that the max element number of heaps in the element is going to be only at most 6000, right? 3 times 2000. And you can kind of just, you know, if you want to check for yourself, you can also just take a look at it. And you see that even for 1690, we only have 360 things in active queue, right? Because a lot of the things we've already seen, and a lot of duplicates and stuff like that. Yeah, that's all I have for this one. Well, let's go over the complexity really quickly. This is unfortunately still going to be exponential time, right? Because remember, exponential time is in the size of the input. And the size of the input is not the number n. The number n is represented by log n bits, and log n is the size of the input. And so this is going to be exponential on top of that. Probably like n times 2 to the n if you ask me. But we can analyze this, which is that for each n, there are going to be 4 heap operations, which are log n each, right? And as we said, there are at most 3 times n number of things in the heap, so there's going to be log n each. So in theory, this is going to be, this is going to be n log n, but keeping in mind that n log n is not the size of the n in this case is the number n, not the size of the input n. So therefore, this is exponential, which is n times 2 to the n, but also not this n. It's kind of confusing to say because they use n. Okay. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Good luck on the contest. We're doing it. Bye-bye.